Welcome to our April 2014 Hangout. Thanks for joining us. This month's topic is Multi WAN. First, we'll go over some project news and discuss the Heartbleed vulnerability that's been all over the news of late. First, some project news. We have two new hardware platforms available for sale on store.pfSense.org. First is the long-awaited successor to the Alex from PC Engines, the APU, which we've labeled as the VK-T40E2. It has an AMD T40E CPU, 2 gigs of RAM, an 8 gig SanDisk SDHC card, and 3 gig Realtek NICs. Those are accustomed to people bad-mouthing Realtek, maybe hesitant to buy anything with the Realtek chipset, but it's not as cut and dry as some people make it. Certain implementations of Realtek NICs are broken or buggy, and that's where they've gotten their bad name with some people. They're an inexpensive option versus server-grade NICs from Intel, Broadcom, and similar, which is why they're common in lower-end appliances. We've had some hardware platforms in recently for evaluation for sale in our store with Realtek NICs that had various issues and were eliminated from consideration. But the NICs and the APU are confirmed to work fine. You won't get the same level of maximum performance with as you would with higher-end server-grade NICs, but the APU will give adequate performance for many needs at a lower price point. The second new platform is the C2758. This is a really nice higher-end platform with the Rangeley Atom 8-core, 8 gigs of RAM, 80 gig SATA 3 SSD, 4 gigabit Intel NICs in a 1U rack mount case. It's capable of gigabit wire speed with capacity to spare. That CPU has the AES-NI crypto acceleration, which is supported to some extent today, and better support will be coming in the near future. It also supports Intel Quick Assist, which is another hardware acceleration technology for cryptography, data compression, and pattern matching. pfSense doesn't yet take advantage of Quick Assist, but that is coming in the future as well. So this is a fast platform today with even greater capabilities coming in the future. Both of these new platforms also include our new annual support option. This includes scope-limited email and live chat support on this specific piece of hardware. This is a change for those who are accustomed to our hourly support option, which also includes phone support and is more minimally scope restricted. The scope is limited somewhat at our discretion depending on the circumstances, but generally speaking, it's limited things in the base system in basic configurations and offering advice on general best practices. If you need more hands-on assistance for more involved tasks like walking you through configurations or doing the configuration entirely for you, that still falls under either our hourly support or professional services offerings, depending on the specifics of the circumstance. A bit on the Heartbleed vulnerability that's been all over the news of late. This is an OpenSSL security vulnerability leading to the disclosure of memory contents to anyone who can communicate with an impacted service. This is mostly relevant to HTTPS servers, but OpenVPN can also be vulnerable depending on the configuration. In regards to the pfSense base system, this affects all 2.1x versions prior to the 2.1.2 release, including 2.1 and 2.11 releases and all 2.1x snapshots prior to the 2.1.2 release. And some 2.0x packages are potentially impacted as well. 1.x and 2.0x versions aren't impacted in the base system. That doesn't mean you need not upgrade those systems, as there have been a variety of other security updates in the meantime, especially going back to 1.x versions. Generally, none of them are as easily exploitable as Heartbleed, but no one should be running anything older than the latest 2.1x release at this time. The primary components in pfSense that are impacted are the web interface and potentially OpenVPN, depending on your usage. By default, there isn't anything listening to the internet, so this is only exploitable from inside your network in a completely default configuration. You really shouldn't open any management interface of any device to the internet. Our code base is better than many from a security perspective, especially compared to consumer-grade routers, where security researchers are routinely finding new backdoors and serious security vulnerabilities. But and we also tend to get patches out more quickly than many vendors in the case of significant security issues. Like for this one, we had a workaround out within 24 hours or so, and a new release out within about 4 days. And that's faster than some vendors could even figure out which of their products were vulnerable. but it's a good example of why management interfaces should not be open to the entire internet. Either restrict the sources allowed to a limited number of trusted IPs, or require a VPN for remote management. OpenVPN is not impacted if you're using shared key. It's only in the SSL TLS modes. If you're using SSL TLS OpenVPN, it is vulnerable in some circumstances. We enable TLS authentication by default for SSL TLS OpenVPN, and where you have that enabled, only people who have your TLS key can exploit Heartbleed in that case. So for most users, that mitigates the most serious potential impact, as only trusted users have your TLS key. In circumstances where untrusted users have your TLS key, usually that's only in scenarios like VPN service providers, it's an immediate concern. We're using SSL TLS and you don't have TLS authentication enabled, you should either upgrade immediately or disable that OpenVPN instance until you can upgrade to 2.1.2 or whatever the latest version is at the time that you're listening to the recording if you're not watching this live. There isn't a public proof of concept exploiting this OpenVPN. However, there is known to be private exploit code that allows getting access to your VPN. Other impacting components include anything dependent on OpenSSL. There were 22 packages in our package repository that included OpenSSL as a dependency. The biggest risk is in any package that accepts SSL TLS connections as a server, especially where those are open to the internet. However, clients are vulnerable as well, if some can make a vulnerable client connect to an untrusted server. Our recommended remediation is to upgrade to 2.1.2 immediately, or whatever the most recent stable release is if you're watching this recording later. One significant caveat for those who have the autoconfig backup package installed, there's a bug in the older versions of that package that will cause problems if you upgrade to 2.1.2 unless you upgrade the autoconfig backup package first. So if you just go to system packages and uninstall and reinstall the package, you'll be on the latest version and you'll be fine whenever you upgrade. And consider reissuing the keys after you patch to get to a version that's no longer vulnerable to Heartbleed. If you're using an SSL certificate from a trusted certificate authority for your web interface and it was potentially reachable by untrusted users, you should have that certificate revoked and reissued. For the default self-signed certificate, it's not as much of a concern since you're clicking through a certificate warning every time anyway, and anyone in a position to take advantage of that doesn't generally need your self-signed cert's private key to do so. For OpenVPN purposes, if you have an OpenVPN server open to the internet using SSL TLS authentication, using SSL TLS and not using TLS authentication, or untrusted users have your TLS key, you may want to reissue all your OpenVPN certificates. To really be on the safe side, make notes of how your OpenVPN server is configured, then delete it and delete all of its associated certificates under the System Cert Manager, and then reconfigure everything from scratch, including creating a new certificate authority, server certificate, and client certificates. Probably not something that most people need to do because you're probably using TLS authentication on it, and you probably are not handing out that key to just anybody, and hopefully you're going to patch the system pretty quickly, so that's probably not something that you need to be concerned about. But if you are in a position where someone could have potentially obtained the your certificates, then you'll want to reissue everything and get new certs out to all the clients. The biggest concern with Heartbleed for most networks will probably be in non-pfSense related things. Check all your HTTPS servers in particular to ensure they're not vulnerable. The site here on the screen here will allow you to enter a host name or IP and a port to check to see if it's vulnerable. That's one quick, easy way to check. And there are also tools that you can run on your machine to check those things. Be careful what you run those test tools against, as there's a possibility you could crash certain embedded devices, like reportedly HP ILO management cards will crash and stop functioning until you unplug power from the server and power it back on. Even though they're not actually vulnerable to Heartbleed, they don't use OpenSSL, but they will. There's a possibility that you crash things if running the test tool against them. I haven't heard of that happening with any standard web server software or any non-embedded device. So you can be pretty safe in checking your HTTPS servers that they won't actually have any problems. And then after patching your servers, public ones in particular, you should consider getting your SSL certificates revoked and reissued, especially if your server was left vulnerable for very long. Because the longer it was left open, the more likely someone got the private key of your certificate, which will compromise the security of your site unless you have that cert revoked and replace it. For things other than HTTPS servers, check with the vendors on other products on applicability. Very important for anything that's open to the internet or any other untrusted networks. Okay, on to this month's topic, Multi WAN. First, going over the goals and strategies of a Multi WAN deployment. The main reason people want Multi WAN is for redundancy. Many companies are highly resilient on internet connectivity to the extent some or many employees are incapable of doing their jobs without it. Having multiple connections reduces the chance of losing your internet connectivity. Bandwidth aggregation is another reason some people want Multi WAN. First, let's define bandwidth aggregation in this context. If you have, for instance, two 10 meg connections, Multi WAN won't give you the equivalent of a single 20 meg pipe. A single connection will be limited to the bandwidth of the internet connection it gets sent out of. It's just the nature of how TCP/IP functions. A single connection can only use one IP, and that IP is associated with only one internet connection. You can achieve the aggregate total throughput across multiple connections, like if you're using a download manager that opens multiple streams or have multiple devices inside the network making requests that get balanced out across the connections. Aggregation of bandwidth in a way that allows a single connection, generally a single TCP stream, to achieve the speeds of multiple connections combined requires the involvement of the ISPs. That may be MLPPP or having a provider-independent direct IP assignment and using BGP to announce your own routes to the internet. These aren't really practical options for most small to mid-sized companies. Options like MLPPP aren't widely available, and where they are, they commonly aren't the best option for Multi WAN because they require the same type of connectivity to the same ISP, so they offer much less redundancy. Provider independent IP assignments that are necessary for BGP are impractical in most such cases because most networks of a smaller size can't provide adequate justification to receive the minimum /24 allocation of IPs. And most all ISPs are unwilling to offer BGP service on your lower cost internet connections like cable or DSL. And the types of connections where they are willing to offer it are cost prohibitive, fiber, DS3, and other types of much more expensive connectivity. The other option you'll see on some competitive products is tunneling all of your internet traffic out to a data center somewhere and out to the internet from there, where there's much more available bandwidth. But that's not nearly as good as what those vendors' marketing materials would try to make you believe. It does allow you to obtain the aggregate throughput of all the connections with a single TCP stream, for instance. But bandwidth is only one component of network performance. Tunneling traffic out through a data center like that adds significantly to the latency in most all circumstances, potentially doubling the latency or more. And it also adds jitter. For many circumstances, tunneling traffic in that fashion will actually reduce performance. Much of what you do on the internet isn't bandwidth limited, like web browsing, for instance, rarely requires a whole lot of bandwidth. How fast pages load is influenced by round-trip time for DNS and HTTP requests. So significantly adding to the latency of your connection will actually reduce performance in cases like that. Other services like VoIP require relatively minimal bandwidth, but are extremely sensitive to latency, jitter, out-of-order packet delivery. That's unavoidable when you're doing things along those lines. So, VoIP quality is actually likely to be significantly worse if you do something along those lines. And other examples like anything that requires back and forth interactive traffic like Microsoft Remote Desktop or similar remote access. The bandwidth required is also relatively minimal there, but latency is a significant impact on the performance of the connection. So if you double your latency on a remote desktop, you're going to really notice the responsiveness of the connection goes down. There are some limited circumstances where such tunneling is a good option and will help performance, but it's expensive, and in most cases, it's not all it's cracked up to be. The bandwidth aggregation reasoning is most common in parts of the world where higher speed internet connections are either unavailable or they're extremely expensive. Like I've heard of some of our users in parts of the world with relatively poor infrastructure where the best connectivity they can get at an affordable cost is something like a 256K or a 512K DSL line. But they have dozens or hundreds of clients that need significantly more bandwidth than that. So they load balance across many connections, 10, 15, sometimes more. With that, many WANs usually have what I typically refer to as a multi WAN on a stick deployment, taking from the router on a stick term that's referring to a router with a single interface with multiple networks going across it with VLAN tags. So you could have a switch configured with one VLAN per port and a VLAN trunk port with all the VLANs tagged going back to the firewall. So with a circumstance like that, with a 24-port switch, you can have 23 WANs on a single NIC of the firewall. That's documented with diagrams and other specifics in the book, so you can check out the Multi WAN chapter there for more info on that kind of setup. For those of us in countries with better infrastructure where individual internet connections offer much higher speeds, load balancing many times doesn't offer any benefit at all. Unless you're routinely maxing out your connection speed, you probably don't want to load balance in those cases. Where one connection is fast enough to handle all your bandwidth requirements, it's best to leave all your traffic on that connection and then fail over to other connections if that one fails. Usually you have one connection that's faster than the other, and so then if you actually send traffic out the slower connection via load balancing, it will be restricted to whatever the slower speed of that connection is. So you'll actually reduce performance in that case if you utilize load balancing. And another common multi-WAN strategy is for isolation of priority services. Most commonly, this is for VoIP purposes, where individual internet connections available to you are relatively slow and you're pushing multiple simultaneous calls across the internet. Traffic shaping makes it possible to share a single internet connection for quality-sensitive services like VoIP and your general internet traffic, but only where you have adequate bandwidth to reasonably do both. Some people prefer just sending all their VoIP traffic out of one connection to ensure quality, and in some cases the available bandwidth is such that your peak simultaneous phone usage would completely max out your internet connection, where traffic shaping would just essentially choke off all non-VoIP traffic, so nothing other than VoIP would function in that case. So that's another common reason to want to use multi-WAN. There may be similar circumstances for other priority traffic in your environment, but VoIP is the most common example there. Choosing your internet connectivity is an important part of any multi-WAN deployment, since redundancy is one of, if not the most important reasons for deploying multi-WAN. You want to make sure your internet connections offer as much redundancy as possible. Multiple internet connections of the same type commonly don't offer you a whole lot of redundancy. Whether multiple DSL or cable modems or any other option, they'll share a significant amount of infrastructure that's susceptible to failures that will take out both. They usually come into your facility on the same copper bundle and run significant distances in the ground or on telephone poles in the same cable. So in those cases, a single cable cut that affects one will almost certainly affect both, depending on where it happens. Certain failures in the central office can impact both as well in those cases, as well as certain issues within the ISP's network. The same is true of any other kind of connectivity where you have multiple cable modems or multiple types of any other connectivity that are from the same ISP. Determine what cable paths your available connectivity options take into your facility, and so you can understand the risk of multiple connections suffering outages from any kind of cable issues. And some locations, depending on where you are, the available cable, copper, fiber, any kind of service you can get that comes in on a line will all run on the same telephone poles and may not be on any kind of ring that offers protection from a single cable cut. fallen tree, accidental cut during maintenance work, vehicle crashing into a pole, or similar circumstances can take out all your landline-based options in most cases. Where quality wireless ISP is an option that makes a good backup connectivity option, especially where you can't get multiple landline-based connections that take significantly enough different cable paths. The quality part is the key there. There are many wireless ISPs with very solid networks, but there are also many with extremely poor practices who have no business running an ISP network. So take care when selecting a wireless ISP that is one who knows what they're doing and has a solid, reliable network. And some companies have multiple internet connections back to the same ISP. For instance, they may have fiber as a primary connection and wireless as a backup. And that offers protection against a number of failure scenarios, but with most small ISPs, it will leave you susceptible to an outage on both of them if the ISP has an issue within their network. With very large providers, that's much more unlikely to be the case. If you take AT&T in the U.S. as one example, their infrastructure that handles their DSL customers is significantly different from the one that handles fiber connectivity. An outage in their network that would affect one of those is highly unlikely to affect both. Still, to be on the safe side, you want internet connections from at least 2 different providers to ensure the least likelihood of an ISP failure affecting both. This diagram illustrates the example Multi WAN deployment I'll be demonstrating. We get a firewall with a single LAN and 2 WAN connections. Starting out, we'll just have a basic 1 LAN, 1 WAN, and then we'll add the second WAN and do all the configuration to accommodate both of them. Okay, so we're connected to the firewall shown in that diagram for the example here. We have the WAN interface is up. It's got its IP configured on it, and we have a LAN that's on 192.168.10. 10.1 is the gateway IP. So first we will go add the NIC that we have plugged into our second internet connection. And that's on EM2. So we'll add that and save. And then we browse to interfaces opt1. We'll enable the interface. We'll name it WAN2. We'll give it static v4. And the IP is 203.0.113.50. It's a /24 mask. This will be information that your ISP provides to you on what your IP configuration should be. And we'll just call this WAN2 GW. And gateway is .1. Okay, and we will save that. And now if we check status gateways, we see it is online, so we can communicate with the gateway at least. Now if we go to diagnostics ping, we can pick the source address of WAN2 that will ensure it goes out via WAN2. And we can try to test pinging out to the internet. We'll take Google's public DNS IP and try to send that out to the internet to verify that the connection works. And we'll see we did source it from our IP that we just added on our WAN2, and we are getting replies. So we have basic connectivity, at least out to the internet. Now, the next thing you want to look at on a multi-WAN deployment, if you go to system routing, we have our 2 gateways here, and you see the monitor IPs by default are the gateway IP. And that may or may not be okay depending on the circumstances, but in most cases you want to make sure that your hitting something out on the internet. So you're verifying more than just whether or not you can actually hit your gateway. A lot of times your gateway may be a router that's sitting in your facility, so you're just pinging something that's local to you, and not whether or not that router can actually get out to the internet anywhere. So if you a lot of people like to use the Google public DNS IPs here. They're anycasted to thousands of machines, so it's not something that'll go down if one machine goes down. It's usually a reasonably good choice. We'll put 8888 on the first one and 8844 on the second. And then we'll apply changes. And then if we go check status gateways, you'll see that our round trip went up considerably because we were just monitoring the local router in this case, and now we're actually going all the way out to the internet and back to verify that it has end-to-end connectivity. Okay, so then now that the monitors are all set up okay, we add a gateway group. So adding these gateways in and of themselves doesn't actually make the system use them for anything. We'll create a gateway group that we can then specify in firewall rules to actually enable its usage. So the first one we'll create will be WAN to WAN 2, and we'll just set this one to prefer WAN and failover to WAN 2. So the connections on a higher tier are used first, and then it fails over from there down to lower tiers. And there's 5 tiers available, so you have a lot of flexibility in what you can do if you have a whole bunch of internet connections. Okay, and then many times you also want one in the opposite direction of that. If you click the plus to the right of it, you can add a new one based on that one. And we'll call this one WAN 2 to WAN, and we'll flip the tiers on them. And on this one, prefer WAN 2, we'll fail over to WAN. Okay, and then you may want a third as well if you want a load balance. So we'll add a new one here. Call it load balance. And we'll set them both in tier 1. So if there are multiple gateways in the same tier, and that is the highest tier that has any gateways up, it will load balance across both of those. Okay, we have our 3 gateway groups. And now if we go back to status gateways, there's the gateway groups tab, and that's where you can see the status of your gateway groups. So you see that everything's online at the moment, so everything in tier 1 is what would actually be getting used right now. So any traffic that goes to WAN 2 would be on the WAN, and any traffic that's WAN 2 to WAN would be on WAN 2. And if it's hitting the load balance one, it will be balanced between both of these connections here. Now, these gateway groups don't actually do anything unless you assign them to a firewall rule. So we'll go to our firewall rules, and we want it to apply to traffic from LAN clients. So we'll edit the default LAN rule. And down here under the advanced options, we have the gateway option. So the default just means the traffic follows the system routing table, which means your internet traffic is going out via whichever path has the default gateway as defined under system routing. And you'll see you can pick the individual gateways here. That's if for some reason you want to force traffic to only go to one particular gateway and never fail over to another one. And then we have our gateway groups here. So we can pick WAN to WAN 2, which will currently leave the traffic on the default gateway interface, but then when it goes down, it will fail over to the other WAN. And just removing that v6 rules, we don't actually have v6 on this demo setup. It's something we have time to get into today. If we go back and check our gateway groups, we should be going out of WAN. So If we go over here to this test system, this is a machine that is inside the LAN of that firewall that we were just on. And if we browse to a site that tells us what our IP is, okay, so that shows us we're coming from the 254 IP, which is the interface IP of the primary WAN. So now if we go over to that virtual machine, so this machine is the one that client is behind. And let's just unplug the cable on that test WAN 1. So that's the main WAN interface. So this would be more or less the same as going to a physical box and unplugging the network cable out of the NIC. And we do that if we go back here and look at the interfaces again. Oh, we're managing it from that IP actually, so we just dropped ourselves off of it. But if we go back over to here, this machine is accessing it LAN side. And if we go check status gateways, we'll see that that gateway is offline now, and then this one is online. So if we check the gateway groups, any traffic that's hitting that WAN to WAN 2 gateway is now going to hit WAN 2. Since the tier 1 gateway is offline, it goes back to tier 2 in that case. So if we refresh this, and it may require a few refreshes just by the nature of how browsers work with persistent TCP connections. Okay, yeah, it shows that we're now coming from that address, and that's the WAN 2 address. So now if we go back to that VM and reconnect our WAN, okay, this is back up since we can manage it via that WAN again. And if we go to status gateways, it's back up. Okay, so then the system there that we're going out of the WAN to WAN 2 gateway, the tier 1's back online, so we'll go out that other way instead now. This may not be immediately reflected in the browser because it's cached and it has a persistent TCP connection, but if you refresh enough times, you will eventually kick back over to the primary WAN that it's going out of. Now if we go back over here, we can change this to load balancing. And now connections will get balanced between the two WANs on a per connection round robin basis. So every other connection will go out of each of the two WANs. With a browser, you're more than likely not going to catch this properly just by the nature of how browsers function. That you may be hitting the local cache, and if that's not the case, browsers will open a persistent TCP connection. They like to hang on to those for as long as they possibly can. So testing load balancing with a browser is not a good idea for that reason, because you're more than likely not going to get a new TCP connection every time you refresh the page. So something like wget is the best bet, because wget will definitely open a new connection every time that you make a request. In this case, I'm adding the -q to get rid of some of the verbosity in the output, just so we can grep out only the IP line. And -O followed by a dash means to output to standard out. And then if you load pfSense.org/ip.php, it'll tell you what your IP is. So we get the IP of WAN 2 first, just because we happen to hit WAN on the request in the browser. And then if you just keep making requests, you'll see it bounces back and forth from one connection to the other on every request. If you have any other kinds of devices inside your network. In this case, this is the only thing on the LAN here, so nothing else is making any kind of connections. So if you do have other things that are trying to go out, it may not flip back and forth every single time like that, because something else on the network may have gotten that WAN in the process of going through the two. But you should see pretty close to every time it flips back and forth. And in the case of failover, if you or load balancing, if you take out one of the WANs down, it will use however many WANs are remaining in that case. There are 3 other areas where you can use gateway groups in addition to the firewall rules. For failover ones, at least. They're not for load balancing groups. IPsec is one of those. Whenever you create a phase 1 definition, the interface that you have is the WAN to WAN 2. So, it adds all of your gateway groups there. So if you pick WAN to WAN 2, it will bind to WAN. Unless WAN goes down, then it will switch over to WAN 2 automatically. And similar for OpenVPN. The interface options there also include the gateway group, and then that allows you to automatically switch it from one WAN to another if you want that kind of failover for your VPNs. And dynamic DNS is the third location that has the gateway groups defined. So the interface to monitor, you can pick your gateway group, and then it will register the IP of WAN, and if WAN is down, it will register the IP of WAN 2. Going over the NAT configuration in relation to Multi WAN a bit. Port forwards and one-to-one NAT and outbound NAT are all specific to one particular WAN. So if we add port forward on WAN, we get a web server behind the firewall here. It's at 10.10 is the IP of that machine. And now if we go to HTTP on that IP, there's our test web server. But that only applies to the WAN. So if you want it to listen on WAN 2, you just need another port forward. So the easiest way to do that is just click the plus to the right of this that adds a new port forward based on this one. And you'll change the interface to WAN 2, because that's always the interface where that traffic is coming in. The destination address, it automatically changes from WAN address to WAN 2 address. If it's not the actual WAN address that you're using, if you have virtual IPs or something like that, you make sure that you pick the correct IP from the drop-down there. And the rest of it is still the same. Just add WAN 2 there. And apply changes. So now our WAN 2 IP will also answer on HTTP. There's our test web server. So that's how you handle port forwards in multi-WAN scenarios. Any given port forward will only apply to one WAN interface. So if you want it to listen on both, you'll just need to duplicate it so you have the port forward for both WANs. One-to-one NAT is similar in that each one-to-one NAT entry is tied to one specific internal host. So if we were doing a one-to-one that had let's say 253 and an internal IP of say 10.253. So that would apply when you were directing the traffic from that host out of WAN, and only out of WAN. Important thing to keep in mind is that NAT only defines how traffic is translated when it leaves a particular interface or is entering a particular interface, depending. So your NAT config has no relevance whatsoever on where the traffic actually goes. It's just telling it when traffic is going in this particular direction, translate it in this way. So if we wanted to port forward or at 1-to-1 on that 253 for the other connection, then we'd have to pick WAN 2 and let's call it that. And so if the system is leaving WAN, it'll get translated to that IP. If it's leaving WAN 2, it'll get translated to that IP. For traffic coming into the system on WAN, if it's destined to this, it'll get translated back to this. If traffic that's coming into WAN 2, if it's destined to this address, it will get redirected to or rewritten to that IP and pass through if it matches firewall rules that match. Outbound NAT, if you're using the automatic outbound NAT, there's really nothing that you have to worry about configuring. We automatically generate outbound NAT rules for every internet connection, so the hosts that are going out of that internet connection will have their source IP translated to that WAN's IP. So that's fine if you just have one IP per internet connection. Fine to leave it on automatic outbound NAT in that case. If you want to do something more complex, if you have multiple public IPs and you want to NAT certain hosts differently than other ones, in that case you can change to manual outbound NAT. And that will automatically populate the rule set that's generated behind the scenes. So we have 3 rules for WAN and 3 for WAN 2. So then if you have another IP and you wanted to change the outbound NAT accordingly so it goes out a certain way for a particular host, you can start a new rule or add one based on an existing, depending on what kind of setup that you have. And then if you just want to want it to match a single host, /32, and it can be any destination. And then if you had other public IPs, you could pick them from the drop down here, or you can type in other subnet as well. Generally, you'll just pick one of the virtual IPs from the list. And then make sure the ordering is correct for it to actually match. So the first matching rule here wins. So if that rule was left at the bottom there, it would never match and never do anything. So just make sure that the order is such that if there's a bigger match like that your more specific source comes first. There are a few advanced options related to Multi WAN. If you go under System Routing and edit one of your gateways, you'll have the Advanced button here. And this allows you to find a weight that's most commonly used whenever there is differing bandwidth between your WANs, so you can change the weight so one gets used more frequently than another. The latency thresholds are when the gateway monitoring process will, 1, warn you, and 2, actually consider it down. So by default, if the latency hits 200 milliseconds, it will generate a warning. And if it's over 500 milliseconds, it'll consider it down. That's a reasonable value in most circumstances. You may have an internet connection that's not very good quality, and those are a little too low for those cases, in which case you can up the thresholds here. The packet loss thresholds, similar there, where the low limit is 10 by default, so if you have 10% packet loss, it will start warning you. And if you hit 20% packet loss, it will consider the connection down. Sometimes there's not necessarily any relation between your packet loss on your monitor pings and your packet loss on the actual connection as a whole. In those cases, you may want to set it a little bit higher. That's very unusual on a good quality internet connection, though. Generally, if you have 10% packet loss, your connection is more or less unusable, and if it hits 20, it might as well be 100. So that's usually defaults are fine there, but if you have a more questionable internet connection, you may need to adjust those accordingly. And the probe interval is how often it sends a monitor ping out. So the default is once a second. So if you don't want it to monitor that frequently, you can put a higher interval in here, and it'll only do the probe that many seconds. So if you put in 10, it'll do it once every 10 seconds. Down is the number of failed probes, number of seconds of failed probes before the alarm will fire. So if by default, if you are having you have either latency above the 500 limit or you have packet loss above 20% for 10 seconds, then it will consider the connection down. If you have a questionable internet connection, you may want to up that a bit so it doesn't flap a whole lot. Those are all documented in much more detail if you look in the Multi WAN chapter of the book, especially for weight. It'll show you how to make appropriate use of those. There are some other advanced options for Multi WAN under System Advanced on the Miscellaneous tab. One here to allow default gateway switching. So by default, if you lose your WAN where the default gateway is, the system just doesn't have a default gateway to use anymore. Where you're actually selecting in the firewall rules a gateway, that really doesn't matter because you don't need a default gateway in that situation. If you're running something on the firewall where the firewall itself needs to be able to get out and it really needs to have a default gateway reachable, then you can check this box and it will switch the default gateway over to another one that is available if the existing one fails. That is not enabled by default because it's not quite exactly perfectly right in every possible circumstance. There are certain dynamic connection types where it won't switch the default gateway over, but it is something that people will use in circumstances where you need to have the host itself get out to the internet no matter what. And further down the page here, we have the state killing on gateway failure option. So by default, we don't kill any states whenever a WAN connection fails. Sometimes it can be a little touchier than you would like, and that would cause more havoc than is really necessary. We used to do this by default. It really just tends to, in most circumstances, cause problems for people. So it's no longer enabled by default. If you have certain things that have long-lived connections and you have a multi-WAN scenario, like VoIP, for instance, is a common example. If your VoIP phones register out of your primary WAN and then your primary WAN fails and your gateway group switches over, all new connections will go out your backup WAN in that case. But anything that already has an established connection, it will continue to follow that state that it had created at that time. For something like VoIP, those states stay active indefinitely in most cases. So, and they're continually sending traffic out that matches that state, so it keeps it alive as well. Even though the WAN is down, it'll keep that state there, and they'll never try to go out the other WAN. So if you change this option so it does flush your state table whenever you have a WAN failure, then the next packet that goes out from the VoIP phones or whatever it is will create a new state and go out of the other WAN. That can be a bit disruptive to wipe all the states. There's no ability to selectively kill states in those circumstances, so it's something you may not want to do, especially if you have an internet connection that's a little questionable and it normally flaps a little bit anyway. But yeah, if you have a case where you absolutely do not want any of your other connections active anymore. If a WAN fails, so everything will start going out the other one, this is the option you want to enable. And then one other option here, to skip rules when the gateway is down. So by default, when the rule has a specific gateway set and that gateway is down, the rule is created without that gateway specified. So if you had a LAN rule, let's say, and let's say this particular host we want to send out of WAN all the time. So we point it to WAN GW. And then it would actually have to be above that for it to do anything. So that's forcing it out to that particular WAN. So if that WAN went down, that rule would be created without specifying the WAN there. So it would follow the system routing table in that case. If you don't want that to happen, you can check this box and it will completely skip that rule if the WAN is down. I'm going to configure a LAN 2 on here, just to illustrate how policy routing can have an impact on your local networks. And it's on EM3. Let's go to OP2. Call that LAN 2. Give it a static v4. And we'll apply that. An important thing to keep in mind is any firewall rule that specifies a gateway will, by design, force traffic to that gateway. It will override anything that is in the system routing table, which is what you want, but it creates some potential caveats that you may not get the first time around unless you pay attention to how it works and understand that by design it has to force traffic to the gateway that's specified. Get rid of that rule. Then we have a host on that network. Which should be 11.10. Let's make sure we can reach it. Yeah, okay. So if we go back here to our host that's on the LAN network, we can't ping that host that's on LAN 2, even though we're allowing all traffic from the LAN. Now if we go look at our state table and filter it on that IP, you'll see here, there's our 1010. That's the source of the machine where we started the ping. And the middle one means it's going out of WAN 2. That's WAN 2's address. So, and then trying to get to that destination. So it's actually sending it out to the internet in this case to try to reach a local network. If we go back to our firewall rules and LAN, okay, now we see why. Everything from the LAN network we're forcing to the load balance gateway group. So that means nothing is going to be routed internally. It'll either be sent to the WAN gateway or WAN 2 gateway. So we need a rule to not policy route traffic that's trying to reach LAN 2. So we do source of LAN net, destination of LAN 2 net, and allow to LAN 2 no policy routing. And make sure it's the first in the list, or at least above any rule with a gateway specified that would match. And we'll apply that. Still no ping. That's because the state is still there. If we go back to diagnostic states, and filter on that address, we'll just kill off both of these. And then if we filter again, you'll see we've got the two states for that, and there's no more NAT involved. And if we go back over to here, we're getting replies now. So that's something to keep in mind, whether the networks are across VPN or they're on a separate interface or VLAN of the local firewall. Just always remember that if you specify a gateway on a firewall rule, it forces the matching traffic to that particular gateway. Some troubleshooting tips for some of the most common issues that users encountered. These are detailed in greater length and depth in the book in the Multi WAN chapter, and that's probably your best reference point when troubleshooting such things. Verify the configuration of your firewall rules. Most of the time, there's something about how the firewall rules are configured. Either they don't specify the gateway or gateway group, or they're not in an order where they match correctly. Remember, the first match wins, and so make sure that the order is such that that the traffic will match the rules that you want it to match. If failover isn't working, but your firewall rules are otherwise correct, check status gateways. Usually that's because the monitor IP on that gateway is a local router or something else that doesn't actually test whether or not you can get all the way out to the internet. So set the monitor IP accordingly so it monitors traffic out to the internet in that case, and that's usually the resolution for those kinds of circumstances. It's that it's still, as far as the firewall knows from your monitor IP config, the connection is still up. If load balancing isn't working according to expectations, that's most commonly one of two things. Validate your testing methodology first. We saw in the web browser when we were testing it that it really hangs on to its one TCP connection and doesn't try to open up another connection. So don't test with a web browser. Use something like wget, and we saw with wget every single time it changed IPs there because it has no cache that may be impacting things, and it doesn't use persistent TCP connections. And make sure they have the appropriate expectations. Recall from the earlier discussion a bit ago that multi-WAN load balancing doesn't get you the sum aggregate throughput of all the connections you're load balancing across when you're testing with only a single connection, is that any one connection in particular must be tied to one specific WAN only. All right, thanks for attending. Any questions? Question about scenarios where the monitor IP that's out on the internet responds, so the connection is at least somewhat working, but the ISP is having issues within their network that's affecting significant portions of the internet, and how to best accommodate that. That's a very unusual circumstance. Most always you're either going to be completely offline or completely online, but things like that do happen from time to time. There's not really a means of detecting that automatically. If your monitor IP is reachable, your connection is considered up. We've considered in the past and may implement at some point in the future the ability to monitor more than just a single IP. That could be one way to help in those circumstances. But even at that, it wouldn't necessarily detect those kinds of issues depending on however many or what the specific circumstance or problem is. With any reasonable number of monitor IPs, you would still potentially miss situations like that where there's a big chunk of the internet that's not reachable that way. So yeah, if you run into anything along those lines, manually disabling the WAN in question is your best bet. There's a few different ways to accomplish that. Probably the best is just to edit the gateway group or groups that are using that WAN, and set the tier for that WAN to none, and that'll take it out of those. And that way you're also only impacting your outbound traffic. If you're natting something in on that connection, that where the remote host that's coming in can still reach you, then that'll continue to work in that case. You could completely disable the WAN, but that's probably overkill, because in that case usually you'll just want to change your outbound traffic to not use that connection. A question about using 3G or 4G internet for backup purposes and whether dial-on demand is supported. A number of people do use 3G, 4G for backup connectivity. We support a number of USB modems. There's a list out on doc.pfSense.org that's it's got at least a few dozen different modems on it that are supported, and there are probably others that we're not aware of. People send us in new ones all the time, so we're always expanding that list. And some people use external routers or mobile hotspots like a MiFi, where you can connect to that from pfSense using an 802.11 wireless card or Ethernet if it's a router that has Ethernet on it. Where the modem is connected directly to the firewall, our PPP implementation does have a dial-on demand mode. It's a checkbox in the PPP config. By default, it'll try to stay connected all the time. That might be desirable rather than relying on dial-in demand and having it fail to connect whenever it comes time that you actually need it. If you have a service that's built based on time connected, that would probably be desirable, though I think all the ones that I've heard of are built on a data transfer basis rather than the time connected. The one thing you might want to disable gateway monitoring on if you have a 3G, 4G connection, since the by default the 1 ping per second will add up to what's a generally insignificant amount of bandwidth on your typical landline internet connection, but it might chew up maybe 2-3 gigs a month potentially across your 3G, 4G, and that might be half of your month's total available bandwidth. So either you might want to disable it entirely, but you might want to increase the thresholds or for the frequency under the advanced options for the gateway. If you crank that way up so you're maybe only hitting it once a minute or every 5 minutes or something, that way you won't be chewing up nearly as much bandwidth, but you'll still know that it's actually up and it's functioning, so you won't find out when your primary internet connection goes down that your other modem is toast or it has some other kind of problem and is non-functional. That's not the time that you want to find that out. Thanks for attending, and we'll see you next month.